let's do just some general homework problems. These aren't going to be tough problems by any stretch, but you do have to think about them. What are the three methods of heat transfer, and what type of medium do they work in? Okay, do you remember what they are? The first one is conduction. This is when there is some sort of contact. This could be a spoon sitting in a hot cup of liquid. This could be a flame hitting the metal of your pot, of your stove, and that's getting hot and that's touching your stove. Conduction is always contact. C-O-N-T-A-C-T. Having trouble spelling. Second, convection. Convection is always done through waves. So this tends to be done through fluids, gases, liquids. All right, but convection is when the hot air rises and then begins to cool, becomes denser, sinks, and you get this circular. There's always going to be a flow for convection. And three is of radiation. And this tends to be any wave that can move, heat transfer with a wave through a vacuum. Okay, this is the sun. The sun is pretty much always radiation because we're never catching the sun. I really hope not. Kind of warm if you are. Why do lakes and ponds freeze from the top down rather than from the bottom up? That's because water is densest. I can't spell dense. D-E-N-S. Densest at 4 Celsius. So here you have a lake, and it's cold up here. It's freezing. As soon as, say, I have a lake that's at a very lovely 50 degrees, okay, Celsius. It's very warm. So we've had a very sudden cold snap here. Let's think about Fahrenheit for a minute there. This is actually incredibly warm. Tell you what, let's make this 5 Celsius. That's a little more reasonable. So it gets cold. So here it's freezing out here. Say it's negative 20. We're having snow in Houston. All right. What will it do? It will cool these top molecules off. As soon as they hit 4 Celsius, they become dense and they sink. And so you wind up with the water up here. Once it all gets nice and cold, okay, you're going to have 4 degree Celsius water down here and 0 Celsius water here, because water is densest at 4 and actually less dense in a crystalline state. Why does a piece of room temperature metal feel cooler to the touch than a piece of wood or paper? Well, it has to do with heat capacity and which one conducts heat better. If you touch it and it feels cool, all right, that's because it's conducting heat away. And it's conducting heat away if it's a good conductor. Okay, so you have a good conductor conducting heat away. You feel like it's cooler. It's your perception. The temperature is still the same. What is radiant energy? It's energy from the sun. It's energy from electromagnetic waves. All right, it needs no medium. It can travel in a vacuum. What happens to the internal energy of a system when work is done on it? Let's see. First law of thermodynamics says the change in internal energy is equal to the heat added plus the work done on minus the work done by the system. So when work is done on the system, remember I wrote it like this. All right, you're only going to have one work. When work is done on the system, then the internal energy must go up. So it increases. Now remember, the internal energy is directly related to temperature. So if delta U increases, that means the temperature increases. If work is done adiabatically on a system, okay, so this is the work is done on a system. Adiabatically means there is no heat, so Q is 0. So what happens to the internal energy? Delta U is Q plus the work done on. That's 0. So change in internal energy, if work is done on, is going to increase. If work is done by a system, will it increase or decrease, and why? Well, delta U is Q plus the work done on minus the work done by. Remember, this is my formula. This isn't everyone else's. All right. Now let's see. If there's work done by, all right, that assumes there is no work done on, and it's adiabatic, so the heat is 0. So as you increase this negative number, this means you're going to have a negative change in internal energy. So the internal energy is actually going to decrease or become more negative, which also means the temperature is going to decrease. Kind of an interesting concept there. What's the rule of loose electrons in heat and conductors? Well, the loose electrons are what go out and hit other molecules and convert their kinetic energy, or give some of their kinetic energy to the other molecules. So the loose electrons are responsible for allowing the heat to travel.